So the first example that we're going to do to practice some more of this synthetic division is 3x cubed minus 2x squared minus 150, and this is all being divided by x minus 4. So for us to set up our synthetic division, we need that box in the corner. We will talk about what zero to put in there, but what we want to do is we want to look at these leading coefficients. My leading coefficient would be 3, negative 2. I do want you to notice that right in between the x squared, there is no x value, so we have to put that 0 in there. So let's write down my leading coefficients. There would be 3 from the x cubed, there would be a negative 2 from the x squared, there would be a 0 from the x term, and a negative 150 from the, in essence, the x to the 0 power term. You have to have that 0 in there. We're going to add our little line, and we are going to start by bringing down that 3. So let's talk about that number that we put in the box. When I am dividing by negative 4, I want you to think about this just like we had in quadratics. If you saw x minus 4 as a factor, the 0 that would be included in that, the place where your graph would cross the axis, is at 4. So my intercept, my 0, my root, my solution would be 4. So going through synthetic division here, we brought down that first 3. We're going to multiply this 3 by the 4 in the box. 3 times 4 is 12. When we fill in that 12, this becomes an addition. You're taking your leading coefficients and you are adding that second row. So negative 2 plus 12 gives us 10. From here, we're going to go ahead and we are going to again do that same thing. We're going to take this bottom number and we are going to multiply it by the 0. 10 times 4 is 40. And we're going to add again. 0 plus 40 is 40. One more time, we're going to take this bottom number and we're going to multiply it by the 0. 4 times 40 is 160, and we're going to add. When we add those two together, this is 10. This last number is going to be our remainder. Because that remainder is not 0, 4 is not a 0. Not a 0. And because we have that remainder, synthetic division proved that it is not a 0. So how we write that remainder is we take that remainder and we say it is 10 over x minus 4. X minus 4 comes from the original thing that we were dividing by. So let's look at how we actually write our answer. In my original problem, my highest power was a 3. Right here, highest power was a 3. So when I write my answer, we start with x, and it is 1 less power. So my original power was a 3, so I start with an x squared. And then I have a plus 10. I have x squared. This would be x to the first. And 40 would have x to the 0, so we don't need an x in that term. We just need to add our addition signs because nothing is negative. So in the end, my final answer would be 3x squared plus 10x plus 40 plus that remainder of 10 over x minus 4. Let's go ahead and practice another one. We are taking 2x to the 4th minus 5x squared plus 5x minus 2, and we are dividing that by x plus 2. So let's set up our synthetic division. We've got that box in the corner, and let's pay attention to our leading coefficients. This 2 right here has the power of 4, so that is my first leading coefficient. Power of 4, let's go down. Power of 3. I look through my polynomial, there is no power of 3, so that's going to be a 0. Power of 2, so this 2 is my power of 4. Power of 3. Now I go to my power of 2, my power of 1, and my power of 0. I then go ahead and I take a look at what factor we are dividing by, and if x plus 2 is a factor, if it is a factor, then my 0 would be -2. So -2 goes in our box. We set up our line, we bring down that first number, and this is where our multiplication and add process starts. We multiply this 2 by the -2 that's in the box. This becomes a -4. We add -4. I'm going to take that bottom number and I'm going to multiply it by the -2 that's in the box. This becomes +8. We add. This becomes a 3. I'm going to do that process again. I'm going to take this bottom number, I'm going to multiply it by what's in the box. This becomes a -6. I add. This is a -1. One more time. I'm going to take this -1, I'm going to multiply it by what's in the box, and this becomes a +2. We add, and because this remainder is 0, you just proved to me that -2 is a 0. If we were to graph that polynomial in our calculator, it would cross at -2. So let's go ahead and write our final answer. My original problem started with that power of 4. So when I write my solution, we go to one less power. So I have 2 from right here, x cubed. It's power -1. I started with a power of 4, now I have a power of 3. -4, next power is power of 2, plus 3, power of 1, -1. So that's what's left over. Let's do one more. So I'm going to ask you to go ahead and divide x squared plus 5x plus 6. And we're going to go ahead and divide that by x minus 1. So we're going to set up our box. The 0 that we'd be looking at is +1. And my leading coefficients would be 1 from the x squared term, 5, and 6. We don't have to add any zeros in this case because none of my powers were skipped. I bring down that first number. I multiply. I add. I multiply. And I add. Because this is my remainder. And because my remainder is not 0, this is not a factor. If I were to graph x squared plus 5x plus 6, it would not cross at 1. But I can write my answer. This is divided by what we were trying to divide by, x minus 1. My original question had a power starting us at 2, so this gives us an x term. It's a power of 1, and then plus our 6, plus our remainder. So if we wanted to rewrite this, this would be x plus 6 plus the remainder of 12 over x minus 1.